All right. So in this problem, we're told that a human can survive a car crash if it's less than or equal to 30 Gs of force. So if it's maintaining under 30 Gs of force, of acceleration. I'm so sorry. I was going to say. And we want to know first off, so one, what is the force on a 65 kilogram person that is decelerating at 30 Gs? So we know that force equals mass times acceleration, obviously. And we have the mass, we want to know the force, and we actually have the acceleration, and that's 30 Gs. And that is literally 30 times the acceleration due to gravity, which is 9.8 meters per second. So if we just multiply our 65 times 30 times 9.8, we'll get our force, which is 19,110 newtons. And that's the standard unit for force. And then second, we want to know what distance are you going to move if you are decelerating at 30 Gs from 95 kilometers per hour all the way down to rest. So for this, we want to find out what kinematics equation we want to use. So what do we have? We have our initial velocity, our final velocity, and a distance that we want to know. We don't have any time. So that actually rules out 3 out of the 4 kinematics equations automatically. So we're left with v squared equals v naught squared plus 2 times the acceleration times the distance, which is delta x. So we know that our v squared is equal to 0. So now we have 0 equals v naught squared plus 2. Our a is 30 Gs, so 30 times 9.8 times delta x. And we know that our v naught is 95 kilometers per hour. But what is that in meters per second? Because that's the standard for velocity. So we've got 1 hour equals 60 minutes times 1 minute, 60 seconds. Okay, we're getting somewhere. We're in seconds. And we also know that 1 kilometer is 1,000 meters. So if you multiply all of that out, you're going to get that the speed in meters per second that you're moving at is about 26.389 meters per second. So now we can solve this. And if you just move these terms around, you'll get that delta x equals, or the distance that you're going to decelerate, or the distance you're going to go before you hit rest, is equal to 1.184 meters. Pretty simple if you use your kinematics equations.